Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about tray-fold cross-validation. So this is one of a technique which can be used to see if there is an overfit in the model that we are trying to build. Overfit is something that needs to be addressed because if there is an overfit, we will be getting extremely good results on our training data set. But if we put our model into the use on the test data set, what happens is the model will fail terribly. So which is something that needs to be avoided, because what happens is when there is an overfit, so generally the data science team would be making some over promises to the business teams with whom they are working on, but actually when the model is put to use, the performance of the model would be really bad. So in order to avoid any wrong expectation, it's always good to see or good to keep a check on the overfit that might happen. So which is very common in case of predictive models. So this is one of the metrics that can be used to measure if there is any overfit that's happening in our data set, and then keep a check on it and ensure that overfit is avoided by building the model in the right way, by using the variables or by using the features in the right way. So let's get into it. Let's see what is tray-fold cross-validation, how it works, what is the logic behind it, and finally we will be going through the implementation using Python script, right? How to implement tray-fold cross-validation in your predictive problem. So what we will be doing is we'll be picking up a simple regression model, and we will be seeing how to implement tray-fold cross-validation. So this can be very useful, like if you are building or if you are working on a regression problem, this piece of code can help you to understand if there is any overfit in the model that you are trying to build. So let's get into the concept. So this is an image which I have taken from Wikipedia. So as you see, so what happens is this is the data set. The balls that you are seeing here are the number of observations that we have. So when we use tray-fold cross-validation, like what happens is tray is the number of groups that we are doing to separate it. So here in this case, what's happening is we are having tray iterations. So this keeps on going like if we say maybe 4, like if we set the value of tray as 4. So let's say for time being, let's keep this as 4, iteration 1, 2, 3 and 4. So what happens is this is the first group, this is the second group, third group and fourth group. So the entire data set is getting divided into 4 different groups. So when we have a value for tray as 10, so what happens is our data set will be divided into 10 equal groups. So that's what would happen. So that's the basic concept behind the value tray. So tray-fold cross-validation means how many groups that we are going to divide the data set into. We will be dividing it into 10 different groups. So usually what you would be seeing is you'll be seeing 5-fold cross-validation, 10-fold cross-validation, so which is commonly used across different models. So the concept is that's what would happen. It will divide the data set into 10 different groups, and what will happen is it will pick up one of the group, set it aside as the test data set, use the remaining to train the model, and once the model is trained, it will try to test it on the other group and then see how good the performance of the model is. The same step will be getting repeated. So for the second time, so for the first one, what would happen is this entire data set that you see here on my screen will be taken for training the data set, and we will be testing using the group that is present here, so which is highlighted. And during the second iteration, what would happen is we will be we'll be training the model based on all these data sets that you see here, that is not highlighted, that is not covered using this rectangle. We will be using the other ones. We will be using the other observations. We will be training the model, and we will be testing the model on this particular data set that is highlighted on a rectangle here. So for each of these iterations, what we are doing is we are setting aside and group. We are just picking up a small group, setting it aside, and we are going to train the model on the remaining data set, and we are going to test it based on the test data set that we have set aside. So which means that when we have a 10-fold cross-validation, what we are doing is we are having 10 iterations. So for we will be having one iteration for each of those groups. In each cases, we will be setting aside a group, we will be training on the remaining data set, and finally coming back to make the prediction on the test data set to measure how good the model is. So that's the concept behind it. So as I mentioned, the steps involved it is first dividing the dataset into k different groups. First one is setting aside one group at a time and then making the building the predictive model, like training the model based on the remaining dataset, and coming back to the data that we have set aside to test, to predict and test how good it is. So this will happen for each of those groups, and finally we take the average in order to see like what is the average performance of a model. Is it good or is it bad? So that's what would happen on a k-fold cross-validation. So now when we say k-fold cross-validation, what are all the different types? So broadly, this can be divided into two types. One is exhaustive and the other one is non-exhaustive. When I say exhaustive, what happens is that logic that I am using in order to divide it into k different groups would be very much exhaustive, as the name suggests, which means that depending upon like what is the various characteristics of the data. So we will be dividing the data based on those characteristics. So on the other hand, when I say non-exhaustive, it simply means that we will be just picking up, let's say there are 100 observations and then we want to divide that into 10 groups. So we will be just picking up the first 10 records, setting it aside as the group 1, second 10 records as group 2, third 10 records as group 3, and so on. So in case of non-exhaustive, what we are trying to do is we are just sorting all the records and then dividing it on a sequence. So when we use exhaustive, what we will be doing is we will not go with the sequence and we will not pick up like the values that comes up with the sequence, whereas what we will do is we will study the characteristics of the data. For example, let's say we have a customer database. So we have something called as an age bucket or gender. So what we will try to do is we will try to see what is the proportion of the customers who are male and who are female, and then we will try to retain the proportion in each of the group that we are trying to have. That's what would happen in an exhaustive way. In a non-exhaustive way, what would happen is we will just sort it and then we will just pick up we will go by the sequence and then we will divide the data set into 3 different groups. So these are all the 2 types that can be used in order to implement like cross-validation. Coming to the next one, like what does the cross-validation results tells us and what it doesn't tells us. Like what are all the cases where it helps us and what are all the cases where it doesn't help us. So the first one is cross-validation provides us a better indication about how well the model would perform on an unseen data. So we are trying to divide the dataset into different groups and then we are trying to make multiple prediction, and by taking the average of all of it, this particular measure will give us a better confidence like how good the model is going to be on an unseen data that we are going to get. So this is definitely something that needs to be incorporated like whatever model that you are trying to build. So the next one is what is the degree of overfit. So it can be used to estimate the degree of overfit. So as I mentioned, overfit is something that needs to be addressed, because otherwise the performance of the training data, the performance of the model on the training data set will be extremely good, and when the model is put to use on the test data set, it will be performing really bad. So it's something that needs to be avoided because it might result in setting up some wrong expectations, and hence this needs to be addressed really quickly. So that's why we use cross-validation, in order to ensure that overfit it can be predicted well in advance, or it can be estimated well in advance, and it can be addressed while building the model. The next one is so cross-validation of course doesn't help us in preventing an overfit. So this is simply a measure, helps us to understand whether there is an overfit or not. It doesn't stop the overfit. So in order to stop the overfit, we use some kind of approaches like kind of a padding and boosting. So here, this particular measure like cross-validation is simply to help us to understand like how much of an overfit is present in the model. So cross-validation is ideal to use when we are trying to build the model, when we are trying to choose what is the right model. So once we have finalized the model, let's say we have finalized like the predictive model that we are going to use, we have finalized all the features that we are going to use, and everything is finalized, we are just moving on, we are going to move on the scripts to the production. So that is not the time to use cross-validation. So cross-validation should be used during the initial stages of the project, when you are still understanding like which model to choose, to understand what are all the different options, like which one is performing good, which one is not performing good. So, but it's not something that can be done towards the end of the project. So this needs to be implemented on the early stages to see what's happening, and based on the performance or based on the results of the cross validation, right, it helps us to choose what should be the model that we should be using, what should be the features maybe we should use, but not something that can be implemented towards the end of the project here. And coming to the next one, like generally this is something that is preferred because so this approach is quite interesting. Like we are dividing the data set into different groups, and then we are going to test the model on different groups, and hence it's something that is really good, and we are going to take the average of it. So this is something that needs to be used in all the predictive problems that we are trying to solve. And finally, the cross validation is good for both small datasets and large datasets. But if your dataset is extremely small, so it doesn't make sense to divide it into maybe 5 different groups or 10 different groups. Maybe that is not, so that is the case where you need to avoid using cross validation because your dataset is already very, very small. So, but usually if you have enough data, like if you have enough training data, so it's always better to use like maybe at least 5-fold cross validation or 10-fold cross validation to see how the model is performing and to see if there is any overfit or not. So these are all the various concepts behind the cross validation. So now what we will do is we will go into the script to see how to implement k-fold cross validation, like what happens in the Python implementation. So going into the implementation here, coming to the script, as you see on my screen, what we are going to do is we are going to first import all the packages that is required. So here in this case, what I'm doing is I'm picking up an regression problem that is already solved in one of the previous sessions. So if you have any questions like how to build an regression model, what you can do is you can go to the description. I will provide a link to the description where I have explained like how to build an regression model, like using few of the algorithms. So here in this case, let's assume that we know how to build an regression model, and the focus here is to see like how to implement the k-fold cross validation. So what I'm doing is I'm going to import all the packages that is required for us to build an regression model. So then we are loading the diabetes dataset, which will be used today. And the next one is we are converting that into a data frame. This is what our data would look like. The next one is just picking up the target value that we are going to predict. And we are using the split functionality to split the training as well as the test dataset. And so this is where we are going to initialize the model. So here in this case, we are using a simple linear regression. So next part is where we are going to implement the k-fold cross validation. So in order to implement the k-fold cross validation, so this is a functionality that is available as part of stl-learn. So as part of stl-learn, like model selection has the cross value store as well as k-fold. These two will be used today in order to implement k-fold cross validation. So as you see on my screen, first we use the k-fold functionality and we pass on n splits is equal to 10. So which means that the value of k here in this case is 10. We are going to divide the dataset into 10 different groups. And when we say shuffle is equal to true, so what happens is while picking up each of these groups, while identifying each of these groups, right, which observation should go into these groups, so we will shuffle the dataset. So it's not going to be in sequence. We will shuffle the dataset. But what you can ensure is you can ensure that each observation will fall only in one particular group. So all of them will be mutually exclusive. There won't be any overlapping between the groups. And we are setting the random state as 100. So that's just a value. That's just a value. Like if we want to get the same values, like we can use the same random state. The next one is we are using the cross val store. So this is where the actual cross validation would be implemented. So here what we do is we pass on the model, we pass on the training as well as the training dataset. So in training dataset we have the dependent variable as well as the independent variable. So we pass on all the values here, and we are passing on how the score should be measured. So when we say R2, it means that the score will be measured based on the R squared value. So the output that we are going to get will be the result based on the R squared value. And CV is equal to folds means that we are going to say that it's going to be 10-fold cross validation, and we are saying that we will be using shuffle, and we are saying that we are using a random state just in case we want to replicate the exact same group in the future, maybe for another run. So this would implement the cross validation. Let me execute it. So as you see on the screen, so what you will see is you will see 10 different measures, because we are using 10-fold cross validation. Value of k is 10 here. So what we are doing is we are making 10 different predictions. So these are all the score for each of those 10 different predictions, and finally what we will do is we will take the average of it. So this is the second one that you see here is another example, so where we use and different scoring like functionality. So here we are using negative mean squared error. So when I execute this one, so as you see that the values would be different, because we are just using a different measure to measure the accuracy of each of those predictions. So even here, if you do the count, you will see that there will be 10 values, because we are having 10 different groups, and we are going to come up with 10 different predictive scores. And so what would happen is we will take average of all these scores to see how good the model is performing. So this is one way that helps us to see if there is any overfit in the data set. So as I mentioned, so this is something that will be done during the initial phases of the project, before the model is getting finalized, before the features that we are going to use will be finalized. So this is commonly used in the initial stages to ensure that we are avoiding the overfit, and it helps us to measure, like to see how good the model is performing. So when we have a number of options, we can use all those options, and then we can use K-fold cross validation to see how each one of them are performing, and based on the results we can choose like the algorithm that best fits the purpose. So that is it about the the K-fold cross validation. I hope you would have learned something new. If you have learned something new, please give a thumbs up and subscribe to my channel. If you know someone who's trying to learn data science and is struggling with the various topics, but there are a number of topics, it's very easy to get lost in the vast number of topics that are there to learn when you want to specialize in data science. So if you find someone who is really interested in learning data science but is lost in the ocean of all the concepts, maybe point them here, because in the 100-day series what we are trying to do is we are trying to learn the various concepts that is very important for a data scientist, like starting from the basic Python to like the Pandas library, NumPy library, or how much you should know on the SQL, like the various concepts in SQL, how to do the visualization, what are all the different algorithms, and we are going behind the concept behind each of those algorithms, how to measure some of those algorithms, and what are all those values. So this is going to be something that will be interesting. Like we will be covering all the important concepts that is required in order to become a data scientist. So that is it for now, and see you soon in the next session. Bye until then.